So alrighty, guys. This is welcome to the end. Let's see. Okay, so it's a few things. You guys got a grade report. The grade report obviously has projections on there. So what does that mean? It just means that if you do no more homework currently, like literally if you did nothing for the rest of the semester, what you need to get on that final to get that letter grade is what's on there. So if it says to get an A, you need a 90, it means you need to get a 90 to get an A, given that you don't do any more homework. Now, you can change those projections by doing more homework. And if you do more homework, obviously all of them are going to be lowered, right? Because you're going to need a lower score to get that letter grade. Now, remember, you want to do the homework. So do the homework. I'm going to extend it, I think, probably today or something, but you will have all that. It's a total of 57 points. But 5 of those points are extra credit, like on top of your, hold on, let me see. Well, actually, no, I think 8 of those points are actually extra credit. So if you do all the homework, you basically get, I think, yeah, 8 points added onto your final. I mean, it's going to reflect. So but yeah, I mean, yeah. So the pack together with, I mean, I adjusted the pack, but pack with the web work add up to more points than is, than is the allotted, the 100 points. So it's built into the homework. So basically, if you were to get 100 on all the tests, on the final, and on the homeworks, you would finish the course with 108. Of course, if you did the extra credit for the test, that actually increases it up to maybe 115 or something like that. But without any of the bonus points or extra credit stuff that we did, all of it has that 8-point extra credit. So it's all built into the homework. Okay, so what else was it? The review, which I have right here. So, so yeah. So yeah, you should still be able to do pack back. I think it should be open. I think you still should be able to put a discussion question on there. As long as I see a response there, you should get the credit. I have to go back and like adjust all the grades because I guess there was like a few mistakes in there. But once I get it all nice and neat, you should get another grade report with the corrected version. We will do more review sessions because obviously we're not going to be able to get through all of it. Well, like half. No. Well, what do you mean by half? Like if you just do like 2 responses. No, so like I said, the entire homework, web work, and pack back together add up to 8 more points than what you should have. Like, yeah. So like I said, if you finish the class with 100 and everything, like literally you got 100 and all the things, you should finish the class with 108. So there's 8 extra points there. As far as the reviews goes, we will probably will hold more sessions so we can finish this up. And also, I think I'm gonna decide to give you guys 2 days instead of 1 for the final. So it'll be on the final will be given on the scheduled day.
Final.
What? Oh. Okay, perfect.
Genius too. I think a bunch of people dropped out of his class. What? I think a bunch of people dropped out of his class. It's a hard.
Are you talking to me? Or if not, then here, let me mute. Okay, perfect. Oh, shoot. Okay, so what was I saying? Yeah, we'll do homework sessions as well. Yes, the homework, the pack is part of the homework. And yes, I will, but I'm going to focus more on the final. Oh, no, you're good, you're good. You're good, don't worry. Yeah, that's right. So I decided to give you guys 2 days. So on the day it's scheduled, which is the 7th, you have all day the 7th, and then all day the 8th. Oh yeah, no problem, man. It's fine. Also, yeah. So basically, I guess what I'm trying to do here is, maybe I know you guys might be freaking out because of those grade reports. Don't freak out. As long as you try, like till the end, and I will be sure that you guys at least pass. It might not be with an A or B, but at the very least, you guys will pass, right? What else? I think that should be it. Any questions? Well, if you keep doing the homework, if you keep going, I mean, obviously, if it's like a 0 and then you go up to just like you only do 2 homeworks, then that's not gonna cut it. But yeah, if you basically if you're showing effort that you're doing the homework. Hold on. So those were for extra credit. So one of the tests had a challenge question, so that gave you 10 points for that. That one kind of died out. But I'm also if you put any discussion on there, I haven't gone to it, but I'm gonna try to like give you the extra credit that if you discussed anything on the challenge questions post on Packback, like trying to solve them. Like if you like say, oh, maybe do this or do that, then I would probably give you some extra credit. Oh, the test average. I think like maybe out of the 4 points, I think the average was like 3 or 2.9 or something like that. So that, like I said, that one was that I put those challenge questions for the first test. It was one of them, and if you did the challenge questions, you would get the extra credit there. Obviously, I wasn't able to really come up with any more because well, semester just got kind of weird. But yeah, if you have discussions on the challenge question posts, you could get some points back on the first test, not anything else. Like I said, I still have to adjust it. Yes, we're gonna do it. I was just answering questions, so might as well start get to it right now. All right, so okay, so hold on. Give me a second. Okay, so this is what I get about pencil. Oh, there it is. All right, so okay, so I'll answer any questions at the end. Let's just do some of the review right now. Okay, so number 1, we have, it says we have Pn, the set of all polynomials of degree n, right? So this is a vector space of polynomials of degree less, I guess, at most n. Let D be the linear transformation from P3 to P2. Right? Okay. How is it defined? Well, it takes a polynomial, x, and it spits out its derivative. Okay? That's what this is right here. So let B be the basis 1x, x squared, x cubed, and I guess C be the, oops, it should be curly brackets, my bad. It should be the basis x plus x squared minus x squared minus 1 minus x minus 2x squared, right? B basis for P3 and P2 respectively. Okay, so we need to find basically find the matrix representation of D. Okay. All right, so let's do this. Let me make this a little small. So here's the solution. So in order to find the matrix that represents that linear transformation, you need to know, so just recall that we need, the matrix can be represented as this. We take D, evaluate at each basis element, I don't know, say V1, or and then find this in the coordinates of C. And you do that for each basis element, and find the coordinates with respect to C, okay? So what do we need? Well, we need to find what D1 is. What is D1? Anybody? What would D1 be? 0, perfect. Yes, I was just making sure. Okay, so dx would be 1, dx squared would be 2x, and then dx cubed would be 3x squared, right? Perfect. All right, so now we have them. The next thing that we need is to find each one of these in the coordinates of C. So how do you find that? Okay, well, oops, no. So next, we find plug-in numbers. Plug-in numbers where? I mean, yes, you're right. We will be plugging in numbers. So next we find the coordinates of each of the above with respect to C. Okay. So we have this basis. This basis C. So let's move on to the next part. You take the derivative of x cubed. Remember the D, what D does, it takes the derivative of whatever you put in it. So the derivative of 1 is 0, the derivative of x is 1, the derivative of x squared is 2x, the derivative of x cubed is 3x squared. Okay. All right, so we have this basis. So we need, okay, so what is this? Okay, so we found the first one. So D1 we need to find this in the coordinates of C, which is, okay, well, that just means I need to find this is in the coordinates of 0 in the coordinates of C, right? Well, how do I find that? So first one is this. How do I find this? Well, I need to write 0 is equal to, well, I need to write it in terms of this basis right here. So it's going to be C1 x plus x squared minus plus C2 minus x squared plus C3. So give me a second. I need to make this a bit. C2 minus x squared plus C3 minus 1 minus x minus 2x squared. Okay. You can rewrite this to be to just gather it. So hold on. So okay, so I'm gonna gather. So you can put, so it's gonna be C1 minus C2 minus 2 C3, all of this, x squared plus okay, so rewrite the other one. So it's gonna be C1 minus C3 x plus, or sorry, or I guess plus C3 minus 1, I guess. Oh, sorry. Well, I guess in that one you can just put C3 minus C3. It doesn't matter. All right. So from here, what do C1, C2, and C3 need to be in order for this to be 0? Well, from here you can just, so setting up a system. Well, yeah, I mean, I guess you can immediately see that this would just be 0, but how you would do it for the rest of them, you would have to do the same thing here. So set up a system, so it's going to be, which second line? This one? Or which one? Oh, the whole thing, okay. Just, I collected the terms. So if you distribute your C1, C2, C3 in and collected everything that had the x squared term, you would get C1 minus C2 minus 2C3, right? I mean, distribute this in. You would get C1 plus C1 x squared minus C2 x squared minus 2 C3 x squared. Factor, yeah, there you go. Okay, so just set up a system like this. And augment it with 0, right? Because each one of these has to be 0. Well, if you RREF this, I mean, you'll probably see that this is just going to be a 1, 0, 0. Which means C1 has to equal 0, C2 has to equal 0, and C3 has to equal 0, right? So that means that the coordinates of 0 respect to C is just going to be C1, C2, C3. Oh, it's the coefficients of these three. So basically, if you okay, so maybe I jumped a few steps, but so from here, right? What is the only way that this thing will be 0? Well, the only way this thing will be 0 is if C1 minus C2 minus 2C3 is equal to 0. C1 minus C3 is equal to 0. and minus C3 is equal to 0, right? So just set up a augmented matrix with that, and you get it. So that means that the coordinates of 0 with respect to that basis C is just going to be 0, 0, 0. Okay. Okay, perfect. So I should a second. Okay, I need to get an RREF calculator on my phone. Okay. And basically repeat this process with the next one. So let's do, so now for do dx with respect to C, which is just going to be the 1 with respect to C, right? So same thing. You're going to basically set this guy equal to 1 instead. And from here, you can see that then the equations become C1 minus C2 minus 2C3 is equal to 0. C1 minus C3 is equal to 0, and minus C3 is equal to 1, though. So the constant term on the left-hand side. So that means that you're going to set up the system 1 minus 1 minus 2, 1, 0, 1, 0, 0, minus 1, 0, 0, 1. Okay, so now let me do this. Okay, so let's see, we have a 3 by 4 system. So I'm going to put in 1, 1, 0, minus 1, 0, 0, minus 2, 1, minus 1. And the only, yeah, 1. Okay, so let's RREF that. And so let's see if I put this in right. 1, minus 1, minus 2. Oh, okay, I was like, oh, shoot, that doesn't look right. I was about to be like, okay, oh, let's just skip this one. But no, okay, perfect. So, okay, so from here, this means that my C1 is equal to 1, C2 is equal to 3, and C3 is equal to minus 1. So that means that the coordinate of 1 with respect to C is just going to be 1, 3, minus 1. Okay? And you do the exact same thing for the next two. So I'm just going to write them out pretty quickly. So, yeah. Sorry? Oh, you mean just solve the system like normal? Yeah, I mean, you could do that. It's just that, oh no, I mean, it doesn't matter. The whole point is that now we have these tools, right, to be able to solve systems, but you can do it. I mean, you can still do it by hand. I don't mind. As long as you, the important, I mean, I'm not, for this one, I'm not testing whether or not you can solve the system, right? You can solve it however you want. You can do elimination or substitution, doesn't really matter. Or you can just do this, but that's what you meant, right? Just yeah, back substitute. Yeah, you can just do that. Doesn't matter. Why did I choose C negative C3 for? Yeah, because over here. So okay, so here let me write this a bit better. So over here we have 0 times x squared plus 0 times x, and then plus 1. So just equate each of the things. So this thing right here goes to this. wouldn't C1 be equal to -1? Yeah, it is equal to -1. Oh, so wait, what? C1 isn't it C3? It's well, so C3. What do you mean by? So negative C3 would equal 1, right? So C3 equal -1. Hold on. Let me see. Let me see the RREF. I got 1, 3, -1 for mine. Yeah, I mean I got 1, 3, negative. Hey, did you get something else? Uh, oh, okay. Well, yeah. I mean, I guess whatever. I mean, like I said, I don't really care for the arithmetic errors as long as you know what the point is. I mean, yeah. Mine said 1, 3, -1. But if yours says that, then I don't just use it. Um. Okay. Anyway, so now x squared. It's because I have a positive 1 on the second row. Oh, yeah, you're right. Okay. Oops. Okay. Yeah, you're right. Should be a -1 right here. Yeah, okay. So yeah, so in that case I got this. Um -1, 1, -1. Is this what you got? Okay. Yeah, okay, so that I mean that just changes it here. So -1, 1, -1. Okay, perfect. Okay, so just do the same thing for the other ones. So you want to find D2 with respect to C. So instead of so over here you're gonna have 2x now, right? So here then you're gonna have the equations C1 minus C2 minus 2C3 is equal to 0. C1 minus C3 is equal to 2, and minus C3 is equal to 0. So set up your system again. Here it is, 2. All right, so let me just augment this. 2, 0. So that means I get C1 is equal to 2, C2 is equal to 2, C3 is equal to 0. So that means the coordinates of x squared with respect to C is 2, 2, 0. Okay, and the last one would be dx cubed. We want to find this with respect to C. So over here, we're going to have 3x squared. So again, I'm just going to have 1 minus 1 minus 2. 1, 0, minus 1, 0, 0, minus 1. So we're going to have 3, 0, 0. So if I do this, perfect. So C1 is equal to 0, C2 is equal to -3, C3 is equal to 0. So that means x cubed with respect to C is equal to 0, 3, 0. All right. Okay. So that means my matrix A is just going to be those 3 things I got, or 4 things I got. So what was the first one? Was 0, 0, 0. What's the second thing I got? 1, negative. Let's say -1, 1, -1. said it and I still said it wrong. Two, 2, 0, and 0, 3, 0. And that's your matrix. That's so yeah. So by the way, so what you're gonna what this matrix does is it actually does take a derivative of any polynomial, but with respect to a different basis. So yeah, cool. All right, so for time's sake, let's skip number 2. We'll do it next time in a session. Let's do number 3. Any questions on this one though? No. Yeah, I already F'd it. I just skipped. Yeah, I just skipped the steps between me. I already F'd it in my calculator. I just skipped the steps just to like save time. Yeah. This thing. I already F'd that thing. Anyway, so this would be 1 respect to C. This would be X respect to C. X squared respect to C. And X cubed respect to C. Yeah. Okay. All right, so next one. Let's do number 3, just to save time. So let V be the space of n by n real valued matrices, square matrices. So we need to prove that the set S that is all matrices in V such that AB equals BA is a subspace. Okay. So what were the 3 things you need to check for subspace conditions? It's always 3 things, right? So the 0 vector, correct? You need to check if this, yeah, scalar multiplication, addition are closed. Yeah, exactly. Yeah, we're skipping it just because it's gonna. I want to do as many as we can, but we'll do like I said, we'll have session. We'll still have more review sessions after this. It will just be through Zoom instead. Because because I need to like do more questions before we like leave here. Okay. So yeah, so 1, we need to check if the 0 vector is in S. Is it? Well, yeah, right. So note that 0 times B is equal to 0 is equal to B times 0, right? So I guess I should maybe so I should say, I guess I should say more precisely B and B, just to be fixed with that. Yeah. Right. Right. This is true, right? 0 times D is equal to 0 times B. I mean B times 0. Right, because they both equal 0. So they both have to be equal. So the zero vector or matrix is definitely in there. All right. What about close under addition? So let A and C be in V. Well, actually, sorry, in S. So A plus C is going to be times B. Well, what is this going to be? Well, it's going to be AB plus CB, right? But since they both come from S, they commute. And then we can just factor out the thing. So that means that A plus C is an S, right? And the last thing is scalar multiplication in. So let lambda be in R and A be in S. Then lambda times A times B, or this is just going to be lambda A B, which is equal to lambda B A, but then scalars can also commute, right? So so this equals just B lambda A. So that means that lambda A is an S. So it is a subspace. Why the C? Because I need to show the addition of two matrices in S is also going to be an S, and so I just picked an A and a C. It doesn't matter. I could just pick D if I wanted to. Just pick two matrices, and it doesn't matter how you label them. Yeah. All right, so that's 3. Let's leave 5 for next time. Let's leave 6 for next time. Let's do 8. Well, I guess we can do 6. Let's do 6. So let x equal 0, 1, 4, minus 8. Write x as a product of elementary matrices. Okay, so first of all, do you guys remember when we can even write a matrix as a product of elementary matrices? Like, are we always allowed to do it? But yes, it necessarily has to be square, correct? But that's not the only condition. Huh? Yeah, it has to be invertible. Yeah, exactly. It has to be invertible, otherwise we can't even ask the question. So yes. So is X invertible? So what's the easiest way to check if something's invertible? I guess if it's without actually computing the inverse, right? Remember there was like one thing like that theorem with all those like equivalent conditions. There's like one that we should probably always use. If its determinant is not 0, right? Yeah, exactly. Not 0. If it's 0, then it's not invertible. If it's 0, not 0. If it's not 0, it's invertible. If it's 0, it's not invertible. So the determinant of x is obviously equal to -4, which is not 0. So it is invertible. Perfect. So we can ask this. Okay, so what do we do? Well, what we do is this. We need to write it in RREF form. So what is the first thing I'm going to do? Well, I'm going to take row 2 and interchange it with row 2. 4 minus 8, 0, 1. What's the next thing I'm going to do? Well, now I'm going to scale the first row by 4. By 1/4. It's going to be 1 and -2, 0 and 1. So now I'm going to get rid of that -2 by doing row 1, replacing it with row 1 plus 2 row 2, which would give me 1, 0, 0, 1. That gives me the RREF form. Now each one of these, I'm going to label these as steps right here, what I did. So remember, we're going to basically, these three are going to be what determines our elementary matrix. So let me take these three. So what is the matrix that corresponds to interchanging rows? It's just 0, 1, 1, 0, right? This will interchange a row. So I mean, if you don't believe me, you can just do it on a matrix. this would equal C, D, A, B, right? So that one would interchange the rows. Okay. What about scaling the first row? Well, if I'm going to do the first row, I'm going to scale that one by 1/4 and everything else 0. Yeah, exactly. Exactly. Yeah, you got it. Exactly, yes. Okay, what about this one? Well, I'm going to change the first row. So it's going to be 1, 2, 0, 1. Yeah. So these will be the 3 that does this operation. So X is going to equal to, well, I did that one first. So it's going to be E1, E2, E3, where each one of those are basically the ones up there. And that's it. That's all you did. So I would suggest you remind yourself how to build those elementary matrices, because remember, I did say there isn't like a good way to explain like how you get them. It's just you just have to remember scaling. Well, I guess we're scaling matrices. If you want to scale the first row, all you do is take the identity and replace the first row with whatever you want to scale, and that would be the elementary matrix that scales. If you want to scale like a bunch of, well, the third row, you'll put like, so if I wanted to scale the third row, for example, like say by 3, then I'll put a 3 down there, and so on and so forth. It doesn't matter how many sizes. So that's for scaling. For interchanging rows, so let's say I wanted to interchange row 1 with row 5, for example, and there was a 5 by 5. So basically, you would just interchange the rows and the identity. So if you start with the identity, oh yeah, I'm sorry. Yeah, you're right. I completely forgot about that. Yes. So, got it. Oh, thank you. Yeah, you're right. It has to be E1 times. So, yeah, I knew I was missing something. Yeah, that's right. Times X would give me the identity, which means that then X would have to be equal to E1 inverse, E2 inverse, E3 inverse. Yeah, so you would have to find the inverses of these, which is easy. The inverse of this guy is just let's see. So you have to, yeah. So it's just going to be itself actually. Yeah, exactly. So that one would stay. The inverse of this one would be well, yeah. So remember the inverse, all that. So remember, the elementary matrix inverse is just the operation you need to get that to be the identity. So for example, E2, what do I have to get it back to the identity? I just have to scale the first row by 4, right? So that means I'm going to scale the first row by 4. So 4, 0, 0, 1. What about this one? Well, that one you can literally see it's just going to be, you just have to add, you add -2 to the, if you scale 1/4 by a half, you get a 1/8. So you have to scale it by 4, right? The first row. So yeah, so to get this one, you have to scale the first row by minus 2. So it'd be 1 minus 2, 0, 1. Right? You have to add the second row to the first row and you get rid of that 0. So this would be the, so this would be the answer. And then that's what goes on there. By the way, if that didn't make any sense, just, I don't care. You can go on the computer, just put inverse in this matrix. It stays the same because, okay, so what do you need to do to get this back to the identity? 1, 0, 0, 1. Well, you need to interchange the first row and the second row, right? Well, in order to interchange the first row and second row, that's exactly the matrix that interchanges the first row and the second row, right? So it's just the same. Yeah, exactly. It should be 1, by the way. Yeah. Any other questions? So I mean that takes care of 1, 3, and 6. Okay, so really we don't really have time for another one, but yeah, I think yeah, I don't really have time to really solve a complete other one, but yeah, we'll still finish the review. But as far as classes, probably tomorrow I'll have it. I'll email it out, and again, I'm gonna record them, so don't worry if you can't make it. I'm not sure yet. I have to decide, but I will record them, so you won't have to worry about not missing it. But anyway, so I mean, but that finishes basically the class, and you guys are basically oh well, I'll send them to you. I'll basically send you the recordings through Google Drive or something like that. I'll have a Google Drive for that. Any other? Yeah, for sure. You guys are also at my last class that I'll teach for probably maybe the rest of my life. But so yeah, you guys. I'm glad I got to teach linear algebra these ones. Yeah. Well, thank you. Yeah. Again, don't. Yeah, of course. Yes. Like I said, we'll still have more sessions. So you guys, like I said, I don't want to fail anybody. My last time I teach, so yes. Okay. Well, if you guys have no more questions, you guys can. Yes, of course. Have a great summer after your exam. All right. Yeah, of course. What time tomorrow? I'm not sure. Like I said, I'll decide by tonight for sure. But either noon or afternoon or morning. I mean, what do you get? Well, I guess it doesn't matter. But yeah, technically this was the last class, but we're still gonna be meeting through Zoom. But last class officially for the semester. But we'll still be. Oh man, well that's a lot. 2 internships. Thing. Is it? Well, that's gonna be a very busy summer. Yeah, mine is just gonna be consisting of finishing my research up and hopefully graduating. Yeah, for sure. We'll still set reminders for the homework sessions and review. I'll set reminds and emails, so don't worry about that. Like I'm not gonna just like expect you guys to know. Yeah, for sure. All right. Any other questions? Nope. All right, guys. Well, oh yeah, for sure. Well, it was a great. Yeah, I'm going to increase the date as well. Yeah, it's still the 4th. Don't worry, it's gonna go up to like the 12th or something like that. Yeah. All right, perfect. Well, for sure. All right, guys. Well, then I will see you guys in the session. If you don't, then I will have a great summer for everyone. All right, perfect. All right, bye.